Hi everyone, my name's Steve Dower. I'm an engineer at Microsoft. I work on the Python tooling in Visual Studio that we're about to show today. I'm also a core C Python developer and one of their Windows experts, so I'm heavily involved in that. Had a lot to do with the changes in 3.5, for better or worse. Today, what I'm going to do is we're going to take a bit of a whirlwind tour through Visual Studio. Now, just before I get started, so I've got some context. How many Visual Studio users are in the room, Python or not, any language? Great. You guys are going to hopefully learn one or two new things, but there's a good chance that you've seen all of this before because you're in that Visual Studio environment, which I'm sure you know and love. For people who haven't used Visual Studio, this is the one tool where you get to live and do all of your Python, get to do all of your C++, whatever other languages you do. Web design is all available in there. It's the one tool that you get to live in and stop thinking about switching between 17 different tools or however you approach it. So what I aim to show, and you can follow along if you like, there's enough detail in the slides that you should be able to do that. Feel free to wave your hand and make me slow down if you're trying to keep up. I'm more than happy to do that. Everyone who's not following along can use that opportunity for questions or just to generally relax and slow down from the hectic pace of a conference. But we're going to go through a range of things that you get from Visual Studio. And when you move from the really disintegrated 17 different tools workflow into having an integrated environment, some of the benefits of that and just the niceness that's all together. And the aim for today. I'm going to build this. In fact, I've already built half of this. But what this is a map of the solar system on a particular date. And I have some nice little controls here I can advance month by month. Fingers crossed for Wi-Fi. There we go. It's still working. And each month, and I can pick an arbitrary date, and it's going to calculate the layout of the planets in here. So there's two components to this. The first one is a basic website written in Python, which we're not going to look at. I did that in Visual Studio. Took me a couple of hours. It's fairly basic. It looks like a developer wrote it. And I stole the images from somewhere who very kindly did not put horrible licenses on them. But the backend service is the thing that we're going to build. So the front of this is a really basic website that calls into a microservice that calculates the locations of the planets on a particular date. And that's the bit we're going to do. So we're using a preview feature of the Azure Machine Learning Studio, which you may or may not be familiar with. I'll touch on that a bit more later. But there's a preview feature that lets you take just an arbitrary Python function and say, publish this to the cloud and give me an endpoint. And you do that, and suddenly you have this REST endpoint to call your Python function and get the results back. And that's running in the cloud. It's got a full Anaconda distro behind it, so you can use pandas, you can use NumPy, whatever one-off calculations you want to do in the cloud. You have access to whatever data you need back there as well. Lets you really quickly publish, and that will happen within the hour, assuming the Wi-Fi holds up. Publish a microservice that gives you a simple Python function that you can call. So I'm going to start with Visual Studio. And the first thing that I need to do is get the source code. So I'm not going to code it all by hand right now. The source code is coming from GitHub. So this is the site, and in fact I should have. That is the site for those following along. Again, fingers crossed on Wi-Fi. This is publicly available. Feel free to take it, play with it, do whatever you like, improve the website part of it and send pull requests for that. I'm more than happy to take any designer contributions there. But this code is on GitHub. It's not set up for Visual Studio yet. It is a pile of Python code that maybe someone's been working on a different machine entirely, someone's been working on Mac, on Linux. They've just dumped the Python files there. And now I want to pick them up and start working with them in Visual Studio. The first step is getting the code into Visual Studio. And before you go and reach for Git on the command line, there's a number of other options. The first one is we have a nice big button down here that says Open in Visual Studio. With Visual Studio 2015, Community Edition, well, all editions, there's a GitHub extension. And the first time you sign into that through Visual Studio, GitHub flicks a switch on your account and any repo you go to will have this Open in Visual Studio button there. So it's now one click to get from the repo in GitHub into Visual Studio with that code. I'm not going to do that. I'm going to copy the URL to the clipboard and jump back to Visual Studio. I already have Team Explorer open. Team Explorer is the hub for working with other people. So depending on the system you're plugged into, Visual Studio Online, GitHub, another Git repo, another Team Foundation repository, this is where you access source code, new commits. You can do all your branching and merging in Git, syncing, work items, whatever collaboration you need runs through Team Explorer. And right now, I'm just going to clone an arbitrary Git repository, which is the one that I copy-pasted, and just hit clone. I do have a backup for this if Wi-Fi fails. And this is all integrated into Visual Studio. We don't install the Git tools behind it. We've had our engineers contributing to libgit2 for a couple of years now, really making that work nicely on Windows. Personally, I find the Git command line completely impenetrable. I'm very much a mercurial guy. But with the Visual Studio support for it, I can actually use it. And so now I have a repository here. If I double-click through that, now I get a set of all the things I can do. We know it's based on GitHub, so a handful of these are going to link directly to GitHub and just open the site. So pull requests, for example, will jump straight to the page. But I can view branches and remotes locally. I can view history and get a graphical representation of what my history looks like. And all of the syncing, branching, and merging, rebasing, which honestly, even with this, I still can't make rebasing work, can be done from here. So there's barely a need to jump to the command line for Git anymore. And if there is, then you're in more trouble than, I'm very sorry. If you need to go to the command line for Git at this point. But we don't have any code visible yet, which honestly I'm very sad about and I'm working hard to fix. But we have a directory full of code, and we can't see the code right now. The current way we have to suck in all the code, Visual Studio is based on projects. For those who aren't familiar with it, it does the directory, basically saying, here's my directory, this is where my project is, doesn't fit the model that Visual Studio has been using for 10,000 years or so. It's based on projects. So you have a file that says, that lists the files that are part of your project. And that lets you more easily deal with noise files. So PYCs never show up in your project because you don't add them. Generated code doesn't show up in your project because you don't add it. It's effectively a list of things that you would want to check into source control. Because we've just checked out of source control, I need to make a new project. And what we've added for Python, because this comes up all the time, is a tool to import from existing Python code. That says from existing Python code. I can't read that from here, so I assume no one else can. And this will jump you into a wizard. Because we've come out of this repo that we just checked out, all the settings are actually really good. So I'm just going to hit finish. And this will generate a Python project with all of the code in it. But as you work with project files, and especially since no one else on any other platform uses them, they're going to get out of date, which is an unfortunate thing. It's something that we are working on, but it's the nature of a project file. This has a list of the files that I care about. When someone else on another platform adds a file and checks it in, that doesn't show up in my project. So when things do change, we have a button up here called Show All Files that's going to add in, that's going to bring in everything that's currently in that directory. This can get noisy, especially in Python code. Suddenly you've got PYC files showing up everywhere. But it does let you do nice tricks like saying all of these views for that website should be included in the project. I actually want those. and I can right-click and include in project, and now they're in. And if I come to a directory that I don't want, like this entire website, I can right-click and exclude from project, and now it's out. And after I've done catching things up to date, then I can turn that off again, and I've got an up-to-date project. That's an unfortunate fact of life right now. We have our fingers crossed that we can fix that completely in the next version, which is some time away yet. But that is how it goes. One of the nice things when it's in the project, source control is integrated the whole way through. So if I now jump over to any of these files and start renaming, adding or deleting things, it's going to update Git for me. So it's already there, it's tracked automatically, or it tracks the deletion. All my changes will just go through. But the whole reason we're here is for editing code. So let's look at the editor. Let's hide that for now. You'll notice syntax highlighting. That's standard. If we didn't have that, then you'd have every right to get up and walk out right now. An editor comes with syntax highlighting. We take that a little further and do really deep code analysis. So if you're used to Visual Studio, then you're fully aware that you get completions for when you start typing things. So I can start importing modules and get the full list of modules available. As I dot through those, I'm going to get a list of everything that's available in that module. And we've done type inference the whole way through Python standard library and all of your code. So as you're passing variables around or passing values around, we track the types of that, which means we know what type everything is at any point. And you can see date time here we know is a class. We know it's a type, so it's highlighted in a different color. And even if I alias that, then you'll see that we flow that through, and we know that DT is a type now as well, and so we give that the same color. And we'll do that for functions, we'll do that for parameters. Functions are currently colored black, so you can't tell, but it's fully customizable. You can choose whichever color you like is going to help you best understand and read the code that you've got in front of you. We also have collapsible blocks. If you've used C#, you will have seen hash region before, and we made that work for Python, because people kept asking for it. But you can also collapse dictionaries, functions, if blocks. Basically anything that takes up more than one line of code, you can collapse to get it out of your way and focus on the stuff that actually matters right now. You'll see here a green squiggly line, which is letting me know that there's a module that's unavailable. So I'm trying to import and use this module. We couldn't find it, so we're just letting you know quietly. It's not going to stop you running Python. There's a lot of ways to resolve modules at runtime that we can't do from an editor without actually running arbitrary code on your machine without asking you. So we'll give you that warning and give you an opportunity to fix it. There's some workarounds that we have to tell the editor without affecting running code. And there should be syntax errors, but apparently everything's good today. So where are those gone? Oh, that's what's happened. Okay. We also have this neat window called the Python environments window for managing multiple Python installations. For people on Windows, this is really common. Our own statistics that we've collected from users show that on average, people on Windows or Visual Studio users on Windows using Python have 3 or more, like typically 2.5, 3 or more Python interpreters installed at any one time. And so being able to manage them is really important. So we have all of them exposed. I have a lot because I'm a developer. We have them all exposed through this window, and we'll let you easily jump to where they are, start executing them, whatever you need to do with it. Let's not pick that one. We also have a concept of the default, which is why the syntax errors weren't there. Because now my default is Python 3.5, and I have red squigglies everywhere I've used print as a statement. It's not much, but it's nice to have that warning up front that the code you just opened is not going to work under your current settings. There's something wrong with it. And we'll do this for a lot of parser errors. We're very gentle about things that may be errors that may not. So PyLint is an option. You can run PyLint, but we're not doing it for you because there's just so many places that we can be wrong. Yes.
Is that just the executable, or is there integration with virtual end and Conda?
Getting to that.
Okay.
You preempted me by about 5 seconds. So, so I grabbed some code off GitHub, and it's missing packages. How do I know which packages it's missing? Oh, someone's left a requirements.txt file in there that says these are the packages you need, which is basically implying that I need a virtual environment. The syntax errors here are letting me know this is Python 2. Sorry, Brett, but unfortunately, the preview service we're publishing to currently only supports Python 2. So I'm working in Python 2 today. So I need a virtual environment, and I need some packages. Over in Solution Explorer, so that window I had before with all the Python environments was global settings. Those are available everywhere to everything. Virtual environments we treat as part of the project. So when you make a project, you can give that a virtual environment and manage that just for that project, and then it stays separated from any other project you have open. So we've really chosen that workflow that people use and strongly encourage that. You can set up a virtual environment and have multiple different projects use it. And I see enough looks of disgust from the audience that you're right, that's not a good idea. If you really want to do that, it's possible. We don't recommend it, and so we don't make it real easy. But what we do make easy is creating a new virtual environment for this project. So I'll right-click this Python environments node and just add a virtual environment. Very simple wizard here. I can choose the name, which I don't want to change. I can choose the version of Python it's based on, which is going to be 2764-bit. And it's already found the requirements.txt for me and tick the box that says go off and download and install these packages. So when I hit create, it's just going to start working. This is not doing anything magical. We're shelling out to the tools in the background. If you don't have virtual env and you run this, it's going to install it for you. And in fact, it looks like it upgraded it for me, which is very nice. If you don't have pip, we're going to install pip so we can install those packages. We're not doing anything new and magical. We are just using the tools that are out there. There is some basic Conda support once you're in a Conda environment, but we don't have any support there to create it. But for the Continuum employees in the room, this is a public extensibility point. And if you would like to add Conda support, you're more than welcome to do that. We're happy to give you info on how to do that. If you haven't got, sorry? If you don't have the text file, then there are currently 2 ways to manage packages individually because we're migrating from one to the other. But currently, they're both available. So over here, we can see I now have the virtual environment with the list of packages installed. I can right-click this and say install Python package and get, again, a simple dialog that will let me choose pip, easy install, or Conda if it's there. And then I can simply finish off the command line and install whatever package it is I'm looking for. The other way is back in this Python environments window, this overview dropdown has a pip view, which will show me what's currently installed in pip. It will give me the versions. It will let me know that there's updates available. And so if I wanted to update setup tools, that's 1 click away to the newest version. And as I search, it will give me the option of simply running the command line. I know that's unreadable, I'm sorry. The first one says pip install whatever I just typed. So if you want to add extra options, you can just add extra options and do whatever you need. The rest of it is search results from PyPI. So it says install Azure Batch Apps, install Azure Blur. I don't know who wrote Azure Blur. Actually, that's not one of ours, but I have to have a look at that. And then just clicking on any of those is going to install that package. And if you don't have pip installed, this entire window just has a big button saying install pip. And then we have some magic to install pip. But after that, we're very keen to just keep using the standard tools. If you install something from the command line, which I can very easily do, I can right-click on the project, open command prompt here. And now I'm in a command window. And it's actually set up to use the virtual environment. So I can wear Python, I can wear pip, and it will show me that the ones in the virtual environment are already set up to use. So just Python, this, pip, install, whatever. And then that will just show up inside Visual Studio as if you installed it through here. So it's a very loose coupling with the existing tooling. So we want you to keep using the existing tooling. But at the same time, any point where you need to switch out of Visual Studio is a failure because we haven't fully integrated your development environment. And so we're always looking for ways to say, oh, people need to switch out here to do this. How do we bring that in so they don't need to be jumping around from place to place? Okay, now that what happened there? Apparently I don't have web browser. And this is where the demo all goes wrong. Okay, another thing I just quickly did, you can have more than one Python environment attached to a project. So if you want to support Python 2 and Python 3 at the same time, you can have them both in there and just easily switch between them. It's just a right-click, activate, and now I've activated that virtual environment for my project. I don't understand why that. And apparently I'm having some other issue that I don't fully understand right now. Oh, okay. One unfortunate thing, this is going to take a while. That type inference I mentioned on the Python standard library, we run that in the background because it takes a while. There's a lot to the Python standard library, full type inference of the sort that like MyPy and a whole lot of tools are coming out try and do. It does take a little while, and until it's completed, we can't give you IntelliSense, which is just an unfortunate side effect of the way the whole system is architected underneath. So what we should be seeing here is those green squigglies go away, but they're not because we're working really hard in the background to get rid of them. Apparently, I installed something that I shouldn't have right before a demo, and now it's taking a lot longer to refresh. But everything is installed, and it's there, so we can move on. Now that I've grabbed this code, what I want to do first is run the tests and make sure that everything's still good. So we have unit test integration just for the basic unit test module. We don't currently have anything clever for nose or PyTest or anything like that. But if unit test discover is going to find the tests, then we will also find the tests. And when you hit run, we'll go through and run them again using unit test. One less reason to jump out of the IDE. Yes?
Is there a way to say, run this script to run my tests?
So the easiest way to say run this script to run my test. So yes, there is, because there is a way to say run this script. So indirectly, there's unfortunately no way to say run this script and transfer the results into this nice looking window is the limitation. But you can absolutely, so I can jump to this test. And I can right-click anywhere in the window and say start with or without debugging. And that has not set up the paths correctly, so it didn't work. But if that is the approach that you want to use for running your tests, then that's a totally fine approach to take. Yeah.
For the test execution, is there a way to tell to execute the tests concurrently instead of sequentially?
No. No, currently tests need to be run sequentially. But you can make smaller selection. So I can grab a handful and say just run these tests and don't run all of them. There's various groupings. So I'm currently grouping by traits for whatever reason. I can group by class and choose just the tests in that class to run. I can group by outcome, so I don't need to see the ones that passed. I'm only interested in the ones that failed. So now I want to see why this one failed, because this is interesting. And this is where we get into one of the coolest things about Visual Studio that it brings to your Python experience, because you can jump around for all the tools that we've seen so far. But it's very hard to jump anywhere that's going to give you a really good debugging experience. So I'm picking up this test that just failed, and I'm going to first set a breakpoint in the test, and now just hit debug on the test. You'll see a bit of flickering, but in a couple of seconds we're going to pop back into the editor and we'll have a nice yellow line on the breakpoint that I accidentally set before. And we'll see a nice yellow line on the line of the test where I set the breakpoint. And now we're here. I have a really cool interactive debugging experience. As I said before, if you've used Visual Studio for other languages, you're totally unimpressed right now because we do this for all of them. So if you're using C++, you get this. If you're using C#, you get this. Using VB, you get this. Using JavaScript, you get this. Using Node.js, you can have this. But we have it for Python as well. And so from here, we're in a test that's testing all the planets. Like I said back at the start, we have a microservice that calculates the locations of the planets on a certain day. So here is that day, which I believe was the day I did the last demo. So it's not quite as applicable today. But what I'm going to do is step in. So there's keyboard shortcuts for all of this, but I'm clicking on buttons for the sake of the video. And now I'm in this function. I can hover over any variable. Apologies for the small font size. But I can hover over any variable and see the value that's currently there. These are expandable where it's appropriate. So this Mercury global variable I can expand. I can see we have big arrays of values that I can expand into. And all that various information. I can even make changes to stuff. So if I don't like the year 2015 here, I can change the value of that. And now I'm working with a different value in that variable. So it's an interactive experience. I get to control when we move to the next step, next line of code. I get to inspect and change if I like the values of any variables at any point. And soon I'll get to see where the errors are. So I can step over that, and now T is the date time. As I keep stepping, you can see we keep executing more code. The autos window is automatically showing me all the variables that are nearby where I am. Question?
When you changed the year, did that change what year reference to? So it changed it globally, or did it just change the local time?
No, so changing variables changes the locals. It's exactly the same as an assignment statement would be. So if you hit year equals 2012, then changing it manually to 2012 has exactly the same implications as that. And eventually, when I step out of this function, I now have the result. So I have this big dictionary of all the results from calling the function, which again is completely unreadable on that screen. I apologize. And now, as I step through the tests, we're going to see that most of these are passing. We're checking for where the planets are. And it broke out at that point because we hit one that failed. So the one that failed was Pluto. If I look at the output from the test, then again, completely unreadable, but it's fine if you're up nice and close to the screen. Assertion error, Pluto not found in the list of planets that we returned. Look, I'm very sad about that, but in its defense, the data set that you use to calculate the locations of the planets is known as the VSOP 87. The 87 means the data set came about, was released in 1987. And at that point, they did not include Pluto. So what the internet discovered fairly recently, the astronomy world appears to have known for a much longer time. Or at least back in the late 80s, they believed that Pluto was not a planet. So unfortunately, that means the test is wrong here, and we should not be checking for Pluto. And now when I go and rerun this test, we should see that there are no further problems with that one. And it will disappear and moved into the past test section, so I don't have to think about it. We've got a nice green bar. The second test, this one is failing with a value error. And it's fairly obvious in this case where it is, but I'm going to pretend that it's not. The way I want to diagnose this is to bring up exception settings. This dialog lets you control how the debugger reacts when certain exceptions are thrown. And so what I'm interested in here is catching that value error as soon as it occurs. So I'll put in a search just to narrow it down and tick that box. So now when our Python code throws a value error, it's going to break into the debugger immediately. It doesn't do the traceback all the way to the top of the program and then say, oh yeah, this is what was happening back when the exception was thrown. it's going to stop immediately. I can inspect the state exactly as it is. I can keep stepping as we go out frame by frame and really get a good view of what led to the state that caused the exception to be thrown. So now that's said, I'm going to start debugging this test. And when that value error is actually thrown, you'll see that we break in right at that line. Where the value error occurred. Day is out of range for month. 2015, this year, month 2, February, day 29. Not the right day to choose, and so we have an issue here. Jumping back up to the test. Did I mention the call stack window? The call stack window shows the call stack. So all the calls that have been made, and we'll let you jump back up. So you can inspect any of the locals in any call frame so far. So you don't have to rely on tracing back through the code and go, oh, this parameter was this argument, which came from here, which came from here. You can actually jump up to the frame and see the parameter where it's being passed in. You can make changes there. That's going to probably confuse you more than anything else if you aren't working in the topmost frame. But you can jump around, and now I've jumped into the test infrastructure, which is going to get messy. But we can see here from the test that an invalid date should return a complete set of planets, but all zeros for the coordinates. This is not an example of good spec writing, because I should not be writing the spec as a comment in the test. But it happens to be where I knew I was going to end up in the demo, so it works well. Question? Sorry? Yes, you can run as many or as few tests as you like. It's all about which ones have been selected from the test window, which I can stop debugging now, so I'll hit stop. And in Test Explorer, I can control, click as many tests as I like and just run those. So knowing now that we have a contract of sorts to fulfill, we should go in and handle this value error. And in fact, you'll see that this is a to-do comment, so I should have been doing this anyway. But there's a nice, easy way that we have integrated here, slight aside. Under the View menu, there's a window note called the task list. And this task list is automatically searching all of your code, and anywhere you have a comment that starts with to-do, it's putting it in the list. And it's doing the same thing for hack, it's doing the same thing for undone or bug, and it's completely customizable. So there's a set of options that you can change to add more tags that you want to automatically add into your task list. And so the Python source base, for example, would have XXX Nick Coughlin for all the places where he's undone stuff, so we can find the things that we need to fix. Hi, Nick. He's not watching. Sorry.
Does that integrate to T-Foundation service?
Not directly. This is, though I do believe it used to in earlier versions, but no, okay. I believe it does in the Enterprise Edition of Visual Studio. So I'm running Community Edition. I can't see it here. I believe there is some integration into the task list for tasks. I honestly have not used it. So we have a task. We need to handle this value error. I could just start typing because we are just going to use an exception block. What I'm actually going to do is use a code snippet. So this is a nice little shortcut that Visual Studio provides for inserting code. And there's two choices. You either insert a code snippet and keep typing, or you can surround with. So I've selected the code that we need to protect. And under Edit, IntelliSense, I have these two menu options. Insert snippet, surround with. You can, when you navigate through the menu, you'll see the keyboard shortcuts for it. I'm going to choose surround with, and choose to surround it with a try block. And so I've just inserted that code. And now I can add in the value error that I want to handle, and add the handling for that. These shortcuts are actually much simpler to just insert. I can type try and hit tab to get the rest of the block completed. I can do the same thing with class to get a class definition created, functions, and these are extensible. You can write your own ones of these. This project, the Python tooling for Visual Studio, accepts contributions, and we would love to have people come and say, hey, I made this cool snippet, would you guys like to include it? We're more than happy to accept those contributions, rather than, as well as people wanting to get deep and dirty with all the C# code running behind this. If that's not to your liking, then anything that makes code snippets more useful for people, and in fact, we're especially interested in Django stuff. So if you have Django code snippets that you just keep using over and over again, we'd love you to say, hey, here's a Django, here's my 5 Django code snippets. Would you like to include them? Because the answer is yes. But now I need to handle this value error. Since I have to return a full dictionary of all the planets, but with an empty value, I'm just going to copy and paste that. And let's fix up the indentation. And now I have the fun job of going through and typing 0.0.0 a lot, which I'm not going to do. I'm going to hit Control-H, which brings up find and replace. And now I'm going to hit this little button here that enables regular expressions, because you'll see that there's a common pattern here. There's the name of the planet, dot position at t, that I just want to replace all of that. And so I can start typing the regular expression. We'll see all the matches within the current selection. And now I've just selected all the bits of code that I need to replace. And that's the result. Replace all, and it's done. That one didn't make it into the slides, so you only get that if you're actually watching this. So now when I go back and run that test, it's returning the expected value. And so it passes. And now we have completely passing test suite. At this point, I would probably jump back to Team Explorer and go to changes, make the commit, probably exclude the project because the rest of my team doesn't necessarily want that, and I can recreate it whenever I need to. Make the commit, and then go back to sync and either push a new branch and send a pull request from that, or if I'm lazy, just push directly to the main repo. The other to-do that we had on the task list, a bit of refactoring work. So like I said, the whole point of this is to publish a function to a microservice, which unfortunately needs a bit of boilerplate code to do that. So I've written that because I was not going to write this live. But it's all just been written under the if name equals main. Looking through it, this is fairly generic code. There's only one sort of real parameter to it, this function that we pass in that we want to publish, and otherwise the rest of it could be reused for a different function. So I do want to refactor this separately. To do that, I'm going to grab all of this code except for the press enter. And under Edit, Refactor, you'll find Extract Method. Again, there's a keyboard shortcut there. Depending on the settings you've chosen, that shortcut will vary. For me, it's Control-R, Control-M. But this will let me take that code and extract it into its own method. This gives you the option of choosing the scope. So if you're within a function, you can choose to extract it to the module level or still within the class. And all the nesting is handled. So this dropdown that only has the module scope in it will have all the levels of nesting you have. So if you're defining a class inside a function, you can extract the method into the class or into the function or into the module. It's any way you want to put it, you can put it. I'll call this do publish. And you'll see there's a preview here of how the code's going to look. Watch this section here. See where there's empty parens? We're not passing any parameters in because we're closing over all the variables from the outer scope. Which are listed here, getAllPlanets is that function. We don't actually want to close over that. We want that to be a parameter. So that to make this function reusable, we want to be able to pass in a different function to publish next time. So I'll unselect that, and now we have that as a parameter. So getAllPlanets is going to be passed in as a parameter. I hit OK, and we extract the method. We keep the scope consistent by returning all the outside variables, which we don't need, so I'm going to delete the returns. But now we have a function. Standalone, separate function, totally collapsible if you don't want to look at it. And the only thing wrong with it is our generic parameter, which is any function we want to publish, is called getAllPlanets, which we don't really want. We want to make this a generic function name. So I can right-click and choose Rename, and we'll call this function. This is different from find replace. Find replace is going to find everywhere that I've written getAllPlanets and change the word to say function, which is not going to be correct. I only want to change it in the context of this bit of code. And so when I preview the results, you'll see that that's exactly what rename does. We're going to change here from getAllPlanets to function, the parameter name. And then the place where we use it in this function, we'll rename it as well, from getAllPlanets to function. But the other location, so where we've passed it in, has not been changed. Where we've defined it has not been changed.
Will that look through the entire code base for that?
That will look through the entire code base that's in your project. This is where the project concept becomes important. If the file is in your project, then we'll find all the references throughout your project. So and in fact, I can show you that because getAllPlanets is referenced in a number of places now. And so I can change this to get all planets except Pluto and preview the changes. And you'll see we've found the one that's in profile test. We've found the places we're using it here. We've found the places we're calling it in the tests. And I can choose to not change some of them, or I can hit apply, and now they've all been updated. Something I missed before is when you're in the test and looking at the function, or looking at the use of the function, you probably want to see the function itself. And so you can right-click and say go to definition, or it's just F12, convenient shortcut, and that will jump you directly to where the function's defined. This also works on a significant portion of the standard library, but not os.path. Do I have anything that I can use? Web browser. I can navigate to web browser in the standard library because we've got that mapped back to the name. So if you have a library that you're looking at that you need to read the full documentation, most of the time F12 is going to take you straight to the original doc string and let you scroll around, copy paste whatever you want to do with it. So breakpoints can be set to, okay, the question is, can you set breakpoints inside? We refer to it as standard library modules. That also includes anything you've installed into site packages. And the answer is yes. There is an option to enable it though. So by default, you can set breakpoints wherever you like. And if we're not tracking the code at that point, you'll never hit it. And so we have an option, tools, options, Python tools, debugging, which is enable debugging of the Python standard library. When that box is selected, then we're going to go through the entire standard library as it goes. So if you have a breakpoint there, you'll hit it, you can step, you can inspect variables. If you're not interested in debugging the standard library, then having this unselected will make debugging faster in general because it does slow things down to be tracking everything. And so when this is unselected by default, you'll get a slightly faster experience in most cases. But if you do need to debug inside an installed module, I believe setup.py develop modules will debug by default. I don't think those are included. Then that option is there if you need it. Speaking of how fast things go, we should profile this function just to find out where the hotspots are. I'm not going to fix anything right now. I have this module, which I've just called profile test, very basic script that just exercises it. We go through a range of dates, and we just call the function. We don't do anything with it. The whole point is to call it enough times to get some interesting results in the profiling data. And I'm going to analyze and launch Python profiling. I can choose all the options I like here to profile whatever I like, whether it's a project or not. In this case, I have an open project that's already set up that I know is working. I've run all the tests. And so I can just start profiling. And this is going to go through, run the code, whatever interactions I have set up. Ideally for profiling, I've taken those out as much as possible. And when that's complete, we get a nice report that can take some time to analyze, but lets you navigate through all the profiling results. You can see the call tree. You'll get percentages of how much time is spent in various places. You have the ability to jump from function to like from caller to callee, jump back to the original source. And you get the hotspot. So the hottest spot gets marked right for you, the hot path. This coord at function, we're spending a lot of time. I can jump through, I can see the function here. I can see that a lot of the time is in math.cosine, which I can't do much to fix, but this is probably the point where I say, oh, I need NumPy to do this for me. I shouldn't be doing it in pure Python code. Or maybe I just reach for number and see if that helps, which I expect it probably will in this case, to optimize that. But it's a really simple way to just get those results. And again, in the interest of using the existing tools, this is based on cProfile. So we're not injecting any proprietary magic into here. The magic is we take the cProfile results and make them browsable. All right, so I've reached the point where I get to actually publish the service. Last time when I did this demo, this is where basically everyone dropped off. And I don't think anyone's actually following along, so it's not a big deal. But this is, so to be clear and complete disclosure, this is a preview feature of Azure Machine Learning Studio. If you haven't seen Azure Machine Learning, you can browse to it. There is a free go and play around with this. What this is Microsoft's sort of managed platform for doing machine learning. So we provide a lot of the primitives, and when I say primitives, I mean sort of fairly high-level machine learning primitives in a simple drag and drop configuration screen, which is not to everyone's taste, but it is very useful for a lot of people who are sort of high-level like getting into things, as opposed to the people that have been working with Python and scikit-learn directly for a long time. We also have publishable web services out of this, which lets you take your data, do whatever training and testing you want to do on that, and publish it as a consumable and importantly, sellable service for other people. So you get a web API out of your data that you've trained a model on, and you can then sell that model. You can sell access to that model to other people. So it's, for example, a web store may come to this service and say, I would like a recommender service. I don't want to figure out recommendations myself. I want a recommender service based on someone's data set. They won't give me the data set, but they will let me access their endpoint to make a request and say, you know, I have this person, here's the last 5 things they bought, what should I recommend them next? And there's a service there that will do that based on someone's existing data set. And the important thing there is if you put up that data set and that model, you get to charge a couple of cents or however much you choose to charge for someone else accessing that service. So it's a really easy way to take an existing data set that you have or an existing model that you've trained, something that you've designed and worked on, and actually make some money off it, and not just either have to keep it secret because it's too valuable, or give it all away and not have any way to either recoup the costs that went into producing it, or even just to live off it. The other really cool thing, which I may get to a little bit later on, if you go through this service and click through that Get Started button and click on the Guest Access button, you get 8 hours free. And then you can click a new button and go to the Notebooks section and spin up Jupyter Notebooks online, which is, again, a preview service that we're working on, but it is going to be the enterprise-ready Jupyter Notebook hosted service. I'll show that a little bit later on, assuming I get the time. So to do all of that, which I'm not going to go through, it is in the slides. There's some logging into a workspace. I've got to get some access tokens. In fact, I am going to have to do that because otherwise I can't demo the publishing. So I'm going to sign in. Hopefully this will work. So the notebooks, for those who are wondering, new notebook, Python 3, Python 2, we have a welcome, we have more samples coming. Right now, I need to grab some information about my workspace so I can publish to it. I'll be switching back and forth, so apologies for the flashing. The workspace ID is how we identify these. Oh, okay, so the Python microservice, I mentioned you can take any ML service that you've made and publish as a web service. The Python is exactly the same thing. We take your arbitrary Python code and publish that as a service. And it's still in preview. There's no marketplace set up for that just yet, but you can take your arbitrary Python code, push it up to these servers that are built for massive scale. The idea is that people can be hitting these servers with requests from all over the place, that you can be reselling these. And so publishing your arbitrary Python code to that is actually a really cool, lightweight way of getting there. So I'm just running the publish script. I don't need that. Workspace ID goes in. I'll need an authorization token, which I'm going to have to regenerate after this. And apparently this is not going to work on the internet in this building. Yes. I'm not doing that on screen. So pretending that all succeeded, this is actually one that I prepared earlier. There is not much left to the demo after this point. Publishing the service takes us back to exactly the starting point that I started from. What I would have been doing and what you can do when you do this from your own home. The top level of this website, which is linked from the slides, has a space to copy in the source and the API key that's generated for your service. And so then you can be using this front-end website with your own back-end service and be generating this map from the microservice that you just published based on a small amount of Python code. So that's the high level of what I had to cover. I do a lot of these demos though, and I've covered basically everything in the product at various times. Does anyone have any requests? Because I'm happy to show you anything in the product. Yes?
So from a debugging perspective, can you actually debug into like C, C++ modules? Or?
I'm glad you asked that, because you saved my plant from asking that. So the answer is yes. This is one of the unique features of, it's not there. This is one of the unique features of Visual Studio that we get to be able to do because we have support for multiple languages in Visual Studio. So being a multilingual IDE, you can, not only can you use Python, C++, C#, whatever languages, you can use them all at the same time. So what I'm opening up here is a sample solution that has two projects in it. One is a Python project. It's called Super Slow Code. It has some basic benchmarks in there for calculating tan H over, 10 million values and putting it into a list. And so I can run that. And there's no way you can read that, I'm sorry. But it's going to take about 6 seconds. 2 seconds. That got fast. Oh, OK. Last time I did this, I was using Python 3.4. I now am using Python 3.5. Last time it took 6 seconds on the same machine. If you're considering moving to Python 3.5, I think I have a good reason for you to do that. I actually have no idea, to be honest. There's some optimization at some point, but the code that we're doing here is this plain old Python code that is iterating through islice. It's an islice over a callable iterator, and it's just calling a couple of Python functions on it, doing some floating point math, and adding it to a list. So possibly the memory allocator on the list improved, because this is 1 million elements. But generally, I have no explanation. I should profile that, though. I did not expect that big a jump. But I can get an even bigger jump because alongside this super slow code that is now just moderately slow code, I have a C++ project called super fast code. And all I've done here, and there's a video of this online. If you go aka.ms/ptvs tutorial, we have a playlist on YouTube. You can also probably just search for it, where I walk through a whole lot of this stuff and then demonstrate this in one of the later videos. This code is basically identical to the Python code. I've done no magic here to speed it up, apart from doing a straight translation into C. TANH was a little bit more work because I'm now dealing with the Python API, so I have a conversion from double to double and then back from double. And the rest of this is, again, much the same code. We're iterating through a sequence, doing the calculation, adding it to a list. The two projects have a reference between them. So if I clean the solution, you'll see that this superfast code module doesn't exist. It's got the green squiggly line. It's referenced from this project. All I have to do is hit build, and in fact I can hit run, and if it needs to rebuild, it will automatically rebuild the C++ code. And now the squiggle's gone away. We know it's there. We have the doc string for the function that we're calling. I don't think we can F12 into it. Nope. And I can now run the third benchmark using the C code, which is down to 0.7 seconds, which is not quite the order of magnitude it used to be. But before any Continuum employees ask, I have not tested with number. But I'd expect it to be faster because I've made no effort to optimize this. But the question is, what happens when things go wrong? What happens when you get an error? And I've obviously demoed this before because my usual error is gone. There's a benefit of an IDE, right? You could accidentally have an if statement without a closing brace and not notice that you've added something that's outside the if statement until you hit semicolon and it fixes the indentation for you. And now it's obvious that you've made an error and a security vulnerability. But for now, I don't have that. So now when I start running, that's the magic before the screen. And in fact, this, I think it's already configured. Nope, okay. So for everyone who missed that error, that said, you returned from a C function without setting an exception. If I run that again, there we go. So in the regular Python debugger, default settings, this is the error you get. An exception pops up, says, hey, this function returned null without setting an error. There's something wrong. So what we want to do is be stepping through it to find out what that problem is exactly. But being a plain Python debugger, if I just set a breakpoint here and run and keep stepping, we're never actually going to hit it because we're not going to step into that function. We're just going to step over it. Because again, pure Python is based on set trace. Set trace doesn't work inside C extensions. Nobody who's dealt with C extensions is surprised. But over in the properties for the Python project, we have this neat little checkbox that says enable native code debugging. So if you come here and check this box, and now when I hit F5 to start debugging, we launch the debugger in a different mode. So it's not pure Python anymore, it's a hybrid. Which does mean that there are some things that don't work that did work in the pure Python one. But now there's some other things that work that didn't work before. So I can still hover over variables and see their values. There's more cases now where we can't edit the values simply because we're in a different mode. But as I step, this time when I step into the fastmap TANH function, I've actually jumped into the C code. And now as I'm stepping through here, we'll see, oh, I was not meant to hit this line. That is clearly where the error is. I can hover over result and see that is not null. We should not be failing. I can expand it. We have a Python view here, which is one of the neat things we add. Because if you've ever debugged Python, like Python's C implementations, it's really, really painful. So what we add when you're in this mode is the Python view, which is not interesting yet because this is an empty list. I'm just going to skip the line and keep going. As I step over, so I've just appended an entry to result, which you can't tell from looking at the high-level description, which is all you get in a regular C debugger. With our extension, I will go to this window instead of using the mouse. When I expand it, I get a Python view. And this Python view shows me how it would be represented in Python. So it's a list with a number in it. So we can see the list with a number. And if I set a breakpoint here and just keep hitting F5, we'll see another number show up. And the list is going to keep growing each time I step through. Eventually, it's going to get to the point where it changes to say, this is a list of length 12, because there's no point showing you all the numbers. But I can expand that out and see each entry of it right there. So when you have mixed C and Python code, you can absolutely debug it. You can build it. You can develop it together. In Visual Studio, we have a template that I really need to get around to releasing that makes building a C extension for Python 3.5 really, really easy. The reason it's really easy for 3.5 is because we changed 3.5 to make it really easy. So unfortunately, it doesn't work well for earlier versions. But it works great for Python 3.5. I can spin up a new extension, build it in debug mode, build it in release mode, build it 32-bit, build it 64-bit, all the cross product of everything that you need, on Windows at least, for a reliable and reusable C extension, you can get. The other thing that we changed in 3.5 over the earlier versions is if you're using Visual Studio 2015, you have the right compiler. Earlier versions, you need to go back in time a long time because there aren't even downloads of the compilers that, well, okay, so there's a download of the compiler that you need for Python 2.7, which you can find online, but there's no IDE integration for that compiler anymore unless you go back in time and find it. So Python 3.5 is really smooth experience now for building through Visual Studio when I release that template. If you'd like that template and you're a Visual Studio user, just come up to me afterwards and I'll give it to you. It's just a small handful of files. But I'll get that online, probably on my GitHub sometime soon. So keep an eye on that and I'll post it there. Yes?
Question. Is there a way in your C++ to specify some kind of special Visual Studio keyword that causes a breakpoint there? Maybe you could say like if this variable is one.
Yes, so there are. Yeah, okay, so the question is there a way in Visual Studio to have the debugger break based on some programmatic condition? So it's not every time you hit a certain line it breaks, it's only if something happens to be set in a particular way. So there's two ways of doing this. The quick and easy way is when you set a breakpoint, you'll notice this little thing pop up with a settings button. This lets you add conditions. So I can make a breakpoint conditional simply by specifying what the condition is. So if I only want to break here when iter equals null putter, I can do that. And now I have a conditional expression on the breakpoint. So the breakpoint's not going to stop if we hit it and that condition is false. But when that condition is true, then we'll stop at that point. There's also an option for hit count. So I can choose to only break on this the 10th time we hit that breakpoint. So the first 9 times, we're just going to go straight through. 10th time we hit it, we stop. And so if you know that something doesn't become a problem until the 999,999th time you hit it, you don't have to sit there hitting continue for a long time and keeping count. Unless you really want to. And this has the option for greater than is a multiple of. If something's a problem every 5th time you hit it, you can say every 5th time we hit this, break. And otherwise it will just keep going. The other way of doing it, which has some performance implications but requires you to recompile, is there is a command called debug break. And when that function is called, it's going to break into a debugger. So you don't ship with that. If you ship with that, your users are going to get very upset because they're going to get pop-ups saying, this program has crashed. We're sending information to Microsoft about it. If they have a debugger, it's going to say, you should attach this with the debugger. And they're going to go, I don't know how to fix this. But if you have some really complicated condition that you want to break on, and you can change the code and insert it, this is going to perform somewhat better. Yes?
Can you show how you change the syntax highlighting?
So syntax highlighting in, let's jump back to the Python code. The options for this are under Tools, Options, Fonts and Colors. And things can be scattered around a bit. There's a few options here that are global to Visual Studio that are shared. So things like comments are going to appear under Comment. And that's all of the comment colors in Visual Studio, including Python. Keyword, I think identifier is in there as well. Number, so if you want to change the color of numbers to bright pink, then you change that in number. And now all my numbers are bright pink. And that also applies in C++ as well, because it's one global setting. There are some that are specific to Python. And so if you scroll down this list to where they start being named with Python, then you can choose different colors for the built-ins. So I think at the moment that's just none. If you want to change the color of none, you can do that. Classes, commas, dots, functions, operators, parameters. Functions, probably the most likely one, because in the default theme, it's colored black. And that's consistent with the rest of Visual Studio, which is why we went with that. But if you want to make that cyan, you can do that. If you want the groupings to all have gray backgrounds, you can do that. If you want parameters to be white on black, you can do that. And now you have a headache. Yes?
I have a question about integration with like Windows Forms and WPF. I do quite a lot of desktop stuff, and I've done like I've used PyCube before, and I've used Insert. Like, I can't find this is like the best idea that's better than like Eclipse, which is like the next best I've found. So
Thank you.
How
I'll pay you afterwards, yeah.
because I've got a load of stuff like that I want to run in Python because it's a bit of Python to C#, but then I want the UI to be Windows desktop
Yep.
experience. Like, how easy is it to pass, say, images from Matplotlib through to Windows Forms? Or is there lots of type conversions?
So it's not so much type conversions. The biggest issue that you face is interop between different language runtimes is the problem here. So if you're working in Windows Forms, you're sitting on top of .NET. If you're working in Python, you're sitting on top of CPython. If you're sitting on top of IronPython, if you want to go that route, then you'll have a much easier time, except then you don't get Matplotlib. So it's probably not the direction you want to go. Every time I personally have wanted to do UI with Python in the background, it's had to go through a sub-process, effectively. So I end up with a Python script. And we have a number of these throughout the Visual Studio support where there is just a Python script that we execute. And we pass in some parameters. So if you're doing that, I would say you're probably making a C# app with the UI that you want. And part of that is going to call a Python script and pass some parameters, wait for it to complete, and then pick up the results off the disk.
So it has to be off the disk, you can't do it.
You can do it through memory. It's easier to do it off disk. Much, much easier to do it off disk.
Would you happen to have any IPython Jupyter integration by any chance?
There is some integration. So I didn't show it in the demo. I skipped over it completely because I got distracted by all the other cool stuff. When I came over to this window, you may have noticed those green buttons to the right-hand side of every single Python environment. Those are going to open an interactive window. like I said, the whole idea of an integrated environment is to take away all the reasons you need to switch to another place, all the reasons you need to Alt-Tab to another window. The aim is to take it away. And so we have interactive windows built in. These are just straight up Python interactive windows. Whatever you type, it's going to execute. We just have Python running in the background, passing it back and forth. If you have a full NumPy, pandas, matplotlib setup, IPython setup, which I believe I do here. Let me check. So when you go to your Python that has all the packages installed, no, it's not this one. No, it's not that one, is it? Nope. I'm sure I have it somewhere. There we go. So when you have one with IPython, matplotlib, NumPy, pandas, your data stack that you work with, we throw in an extra option where for the interactive window you can change the mode. So rather than being a standard Python interactive window, you can choose to make it an IPython-based interactive window. It's not a Jupyter notebook. Don't have that image in your mind. That's not actually what the mode is. The mode enables IPython interaction. So when I start using this now, we're going to jump. Oh, my numbers are still pink. Oh, I don't have PyZMQ. Okay, that's right, I can fix that. So now I have PyZMQ. And so I'm going to jump into an IPython interactive. For those of us who have been using IPython for longer than just the last couple of years, there's a console version, which you use at a prompt. Clearly, a lot of people here have been using it for longer than just the last couple of years, but there's a lot of people who are just notebook. And now I'm in the classic IPython prompt. But because we've enabled that mode, we get also we get the nice printing that you wouldn't get in a regular IPython. A regular Python REPL, but we've enabled plotting. So we have, you can see the signatures for things popping up here as I use them. And the plots are going to appear in line as I create them. So if you're looking for just this basic interaction for the REPL thing, and you have some stuff to do that doesn't require jumping into a full notebook, but you still want to do it. You want to be in this interactive environment. You want the better IntelliSense that we add. You want maybe you really want your pink numbers. You can have them in this interactive mode. But as a good segue, and I think we're running short on time, but as that good segue, when you do want the full notebook, that is where you jump over to our Azure Machine Learning. And from here, this is where you go into our preview service, which is new notebook, and say, I would just like a notebook. Give me a notebook, and we'll give it to you. And this, like I say, this is in preview. We're actively developing this. What time is it on the West Coast? We're actively developing it in about an hour because there's no one in the office right now because it's 9 a.m. But this, I'm normally in there by now, but I'm over here. Hey, Brett's. But we are actively developing this. It is what we're hoping to make one of the first really solid enterprise grade Jupyter notebook services. So, and that means everything along the lines of sharing, collaboration, security, package management that you need for being able to run parts of a business on top of this, to be able to say, hey, my group needs a new Jupyter notebook for every task they do. Go to this service and just get it. It's like someone starts work and they brought in their Windows laptop and you're a Mac shop and you can't set them up just yet. They have this service that they can just go to and not worry about the platforms. Question?
Roughly how soon can I show you all of the money to do that? That would be great.
Unfortunately,
Yeah, the man who collects money just left, but I'm happy to pass most of it on to him. So,
Never spin on that.
yep.
If I throw a massive job at it, how long before I get in trouble?
I don't actually remember the limits that we put on this. I think you're fine for 8 hours, right?
Yeah,
What?
I think so.
I think we get in trouble before you get in trouble. So
Because our team's footing the bill,
If I
so.
want to do some number theory research, this is a good way to do it.
this is a really good way to do it. So the caveats that are here is you do need a Microsoft account if you want your notebooks to be saved. So there's a sort of temp NB mode where you don't need to log in or anything to get into it, but after your time is up, everything's just going to disappear. Once you've logged in, and you don't have to pay anything just yet, it's a free, like there's a free tier for the service, and there's no limits on this, but it will save everything against your own account. So, you know, maybe you come back in a week and we've killed the instance and you've got to rerun everything, but you haven't lost the notebook. Yes?
Can you connect it to like a VPN if you have like a smart cluster or database on your VPN?
Not yet.
Not yet.
Not yet.
Two quick questions, Johnny.
Yep.
So the IPython code that you showed, can you debug that? And the second question, C integration that you showed, can you have that with Cycle?
So I'll answer the first one first because it's more disappointing. Yes, and it doesn't work very well. I would not recommend it. You can debug a regular Python interactive. There's a few tricks involved. That support was added very early on as, hey, wouldn't it be cool if we could do this? Let's do this. Yeah, it works, and now no one's touched it for a couple of years. We're actively looking at improving that for our next release, and that's sort of a big focus. And being able to debug the IPython kernel is also a big focus. That may not be achievable just because of the amount of collaboration that's involved in that and the amount of time people physically have to get something like that going. But debugging the interactive window does work. It can be a little confusing. The last couple of times we've shown it to someone and walked them through it, the model is not what it should be, and so it's not real clear. The second question being, can you use the C++ debugging on Python? So I've talked to various different people. I haven't tried this recently. If Python generates PDB files, well, actually no, because if the build process generates PDB files that can be found, so probably it's going to be DistUtils' fault if they can't be. Or setup tools, maybe, which is a safe, they're safe. We can blame those. No one's going to get upset. But to do that debugging, we need the PDB files, which are generated by the compiler. So they will be generated. They may be put somewhere else and not be findable by the debugger. But I haven't tried that recently. Depending on how Python generates the code, it is possible to have it map back into the Python source. So are you involved in the Python project? No, just interested? If anyone's involved in the Python project or watching on the video, if you start putting the line pragma everywhere you have a line of Python code, the debugger will map back to the original source file instead of the generated C++. But it relies on being able to find the debugging databases, the PDB files. So it is possible. I don't think it's a very smooth experience right now, but that may have changed recently. Yes?
Thoughts on inline temp8 compliance?
I mean, I would love more people to be following that because it means they're working on the Python standard library. And everyone else who's following PEP8 should be tweaking it to their own needs. So having automatic PEP8 right there is not necessarily helpful. Personally, I find it annoying having that sort of style imposed automatically on me. But at the same time, I can see the argument for doing it. And it also annoys me when other people on my team don't use good style. And I would like to impose it. So I can definitely see the arguments for both sides of that. As far as getting it into Visual Studio, it's a prioritization concern. We have such a long list of things to do. That one is second half of the list. And just so it's clear, we're unlikely to get through the first half of the list because there is just so much cool stuff that we're absolutely longing to do. All around data science, we've got great plans. You may have noticed when I was going through those lists of numbers, there's no table view in there. We're really, we're committed to adding that. And I think giving people the choice of, can I view my matrix in an Excel-like grid? Or can I have something complaining when I put a space in the wrong spot? People want the grid. I hope people want the grid. Otherwise, I've really misjudged our user base. Anything else? Yes.
So two questions. You mentioned about fixing the project, the need to create a project file in the next release. I guess, how do you envision that looking? And I guess the second, in terms of, I think you mentioned the Python Visual Studio integration is actually open source. So in terms of extending that, is that mostly in C# or how much of that can be done in Python itself?
So the way I've always envisioned having the directory-based thing is basically what Sublime does, or any of the other editors. It's like, I'm in this directory, just show me everything that's there. And then the trick for us is mapping that into the internal models because we model the entire Python code, and we're modeling search paths. We have an internal sys.path that we use for resolving things, and mapping from a project file where users can easily override it when we guess wrong is really convenient. And as soon as you take away the ability to override that, we have to be really careful that we guess right, because otherwise people are just going to open it and it says, oh, I can't import anything because we guessed that you meant this directory and really you didn't, and there's no easy way for you to say, oh no, I meant this one. So I do envision it working like, open this directory, show me everything that's here, and then magic happens, and then everything works. And we're still working on the magic happens bit. Second question was, remind me?
How much Python?
How much Python is it? Well, okay, so there's an easy way to see. GitHub.com, Microsoft, PTVS is our site. And you can see this big green bar, which lets you know that if you're not a C# developer, there's probably not a huge amount you can contribute directly to the project. That said, we have a number of important pieces that are pure Python code. A large part of the debugger is pure Python so that it's portable. So our debugger will work on all platforms. We can remotely attach to it from Windows to something running on Mac or Linux and debug that. It will work in PyPy and Jython and IronPython because it is just a pure Python component. That can be easily contributed to, well, I say that, I'm not showing you the code for it. If you like refactoring messy code bases, then you can easily contribute to the debugger component of Python tools for Visual Studio. But it is predominantly C#. That's why a lot of our interests and the contributions we're encouraging from this sort of audience is we'd love to have really cool templates. If there's stuff that you just find yourself doing all over and you think, hey, other people would like this, we're happy to put that in. We're happy to credit contributors. If you have code snippets that you just use all the time and maybe you get sick of bringing them forward every time you update, then we'd be happy to look at those sorts of contributions. That's just an XML file. It's not really difficult to write. It's just a lot of the sort of surrounding pieces that plug into the core parts that are written in C#. But it's an extension on Visual Studio. Visual Studio is predominantly C#, C++. So anything else? It is Apache 2 licensed as well. There's a CLA, which is easy to sign, but it's Apache 2 licensed. Really easy to get on board. If you come and post issues, then you'll get one of the team replying directly, probably me. Not if you do it today, I won't reply. But it's a direct line to the development team. We don't have support staff there to tell you to turn it off and back on again before you actually get to speak to someone who knows what to do. It's direct to the developers, and we're happy to help you get started if you want to try and build and make changes or whatever it is you're having trouble with. So I am completely out of time now, so thank you very much. Before I let you go, I do have two quick announcements to make. The first is, well, in fact, they're both after lunch and then after the afternoon break, there are Birds of a Feather sessions going on. The first of those is 11:55. Brett Cannon's going to be hosting 1:55? Yeah, he's here. It's not a very interesting. 1:55, Brett's hosting. What is the title of your forgotten. Python 3, what is
great
it?
or is it great?
Is it great or is it really great?
Just have a discussion.
Yeah.
No bias.
So that will be.
There's bias on my side. I just have your own bias.
So that will be in the BOF room, which is just around the corner at 1:55, and then immediately after the break in the afternoon, I'll be hosting a BOF on Python on Windows. So if you are a Python user on Windows, want to discuss anything, complain about things, ask about things, I'll be there with hopefully someone to shield me from the Rotten Tomatoes. So thanks very much for coming. Happy to take more questions offline, but we're done. Thank you.